And you are live.
Okay, hello.
Hi, everyone.
Hi.
Hello, everyone, and welcome to Decentralizing the Cloud, the promise and potential of distributed storage, part of a series of online meetups for the greater blockchain community. My name is Phil Lusak. I'm an ecosystem communications manager at Parity Technologies, a company best known for Substrate, the blockchain development framework, and Polkadot, the next generation blockchain platform for connecting independent blockchains together. Yeah, today I'm very happy to be joined by three pioneers in the decentralized storage industry. First, we'll have a panel and then a talk later. But for the panel, we're joined today by Pavel Baines, CEO and co-founder of Bluezell, as well as Leo Wang, co-founder of the Crust Network. After the panel, we will be joined by Michelle Lee, product lead at Protocol Labs, who's working on deploying the Filecoin network. So before we begin, we just want to have a few housekeeping information. So we have a poll going on down there, if you click on polls, to see how many people in this meetup are familiar with the Parity's technologies such as Substrate and Polkadot. So please give your feedback if you get a chance. Also, very important, we have questions for the audience to ask by clicking Ask a Question. So at any time during the panel, and also for Michelle's talk, please enter your questions there and then look at other people's questions so you can rank them as well. And we'll get to those later on in the panel. So so let's begin by, let's start with you, Pavel, and then to Leo. Just introduce yourself and tell me a bit about the project you're working on and the problem it's trying to solve.
Yeah, so as Phil said, I'm Pavel, co-founder, CEO of Bluezell. Originally came from the video game space, used to work for Microsoft, Electronic Arts, Disney, and everything was really in digital media. And then just like everybody else, get the Bitcoin blockchain bug, and we're in this space now, or I am. So Bluezell is a database, decentralized database. So we take over the data storage layer. Quick thing of how it came about was we were originally doing blockchain projects for banks and insurers in Asia. So HSBC, OCBC, MSIG, some of the bigger ones. So we did a smart insurance platform, KYC, and it was all done over Ethereum. And when we're storing some of the information and everything was taking off, we're saying, well, we had to use a centralized service, and that was Microsoft Azure then. And that's when it dawned on us that, hey, if everything's going to be decentralized, we can't just have a smart contract for the blockchain be there. The entire infrastructure tech stack needs to be, otherwise we have a weak point in all this. And that's how it came about that a decentralized database could solve all that problems. Other people focus on file storage, and no one was taking the data storage area, and that's what we really focused on. So we were trying to solve our own problem by working with some of these enterprises. Oh, everything just went quiet, Phil.
Oh, sorry.
Oh, there we go.
Yeah, thank you. Thank you for your answer. Leo, tell me a bit about yourself and the project you're working on and what the problem you're trying to solve is.
Sure. Hi, everybody. This is Leo Wang from Crust Network. I am the co-founder of Crust Network and in charge of the technologies and products. And my background is more on the technical side, similar as Pavel. And previously, I was working on working in Microsoft as a development lead, and then in Cisco as a development lead as well. So when I was in Cisco, I was doing like a decentralized. It's actually more like a distributed data storage to manage and exchange all the manufacturing data across the factories that across the world, right? So I'm in charge of that project. So that's where the Crust Network, the idea come from, and that's my background. And essentially, Crust Network is basically a decentralized file storage network of Web3 ecosystem, and the target is to solve the decentralized storage of all the files. And if you look at all the, there are a couple of other projects around this space already, but some of them being relying on supernodes or trustable nodes, right? And some of them are not yet mainnet is not yet launched yet. So definitely we think there's a chance and started this project. Thank you.
Great, thanks for your questions. So to go a little deeper or to understand the kind of enterprises or target markets you're going for, what are some emerging use cases you've heard of for, going for your particular platforms? Leo?
Yeah, so actually, if we look at this area from different angles, for example, if we look at from a blockchain perspective, there are plenty of dApps are in quick developing, especially in Polkadot ecosystem. Like for example, Fala is doing the Web3 analytics dApps, and Darwinia is supporting all the NFT scenarios. Dimension is making all the applications like the mask book. So for those dApps, they all need decentralized file storage, right? So that's one. And on the other hand, if you look at from a traditional cloud space point of view, so two things are actually happening. One is that data is actually blooming, especially at the edge side, because all the cell phones, cameras, and other IoT devices are generating all the massive scale of data. So those data can never be uploaded to the centralized cloud because of the limited public network bandwidth and something like that. So the second thing is that with more and more data on cloud, leaking events happen from time to time. We can see a lot of news around it, right? So to conclude that, dApps needs for decentralized cloud are coming. And we can see traditional cloud users requires something alternative, specifically on privacy protection and wider access. So for those spaces, that's great opportunity or the use cases of all the decentralized cloud storage services. Yeah, that's my point of view.
Yeah, and Pavel, what are some of the emerging use cases you've been seeing?
Yeah, for us, because so those who don't know, in the database sector, we're actually a NoSQL database. So we're really good for specific use cases. And the ones that actually, I mean, there's multiple use cases, but the ones that we see that apply to our sector, that the blockchain, decentralized area is the use cases that work best. We see is from the start, it would be finance. I mean, the first use case is still the best use case. So people who want, they're having customers. Eventually, as regulations, one is when regulations eventually come into DeFi and all that, we still want to protect privacy and censorship. So a centralized database is not going to do that. They can just come turn it off or ask to see that. As a decentralized database, when all these applications are ready and they start migrating over, we can assure them that, hey, the privacy is there because only they've got, it's all decentralized, so no one could come in and look at it. It's censorship resistance that only the owner of the keys, that dApp, could actually change the data, and it's verified by our entire decentralized network of validators to make sure that, like Phil company X and your email list, if you update it, only you can do that, and the entire network validates that. So that assures that no one can basically come in, change the data for you. And also that redundancy of, if you're using, let's say, AWS databases and data centers, if one of them goes down, like Cloudflare went down like a few weeks ago, most of the internet went down with it. Well, because we're stored on all these decentralized nodes all around, even if one node goes down or a whole bunch of them, everything's almost backed up automatically and the redundancy there. So your data is always available. So those ones are really key, we think, is finance, obviously, because you can do certain things with a distributed database like ours, data analytics, better customer reviews. The platforms are going to become more robust that like centralized fintech platforms have for trading. Well, that'll come to decentralized. The second one that we see is media and entertainment, really around chat messaging. If you're playing games, inventory management, user profiles, these are all like behind the scenes stuff that's the player might not really think about as gameplay, but it's part of the user experience. So it'll enhance that. And then longer term, I think once e-commerce starts getting more decentralized, or sites are along that, and content management, a database like ours will be better for inventory management and supply chain in those type of retail online situations.
Okay, yeah, makes sense. Yeah, and you mentioned there's like a lot of like importance for the decentralized applications to have this distributed storage layer. When Gavin Wood came out with his Web3 vision, a big part of that was owning your own data. And so why, specifically for these Web3 applications, why is decentralized cloud storage so important for them?
Starting with me or Pavel?
You can go ahead.
Go ahead.
Yeah, I mean, if you look at the current dApps, like for example, the ones I just mentioned, like if, for example, let's take Maskbook as an example, right? So essentially, they are doing like a, allow users to post social medias on Facebook with all the social media contents hidden behind all the emojis, right? And if they need to store all the like the contents on the cloud, then the content could potentially be audited, right? So that's definitely one very quick direct example. Another example is for the DeFi, like the NFT asset, like all the information, like all the contents, text descriptions, videos, pictures, those can be definitely stored on the centralized cloud for sure. But it's better to be stored decentralized, right? Because nobody is going to like get all the content and modify all the stuff, right? So that's definitely the need from the dApps point of view. And then if you look at other applications other than dApps, for example, we all use Telegram, right? Even for the Telegram, it's better if we can upload our own like chat history onto the, maybe a decentralized decentralized cloud storage, right? So you can make sure that your data, nobody can tamper your data, and your data is actually owned by yourself.
Yeah, adding to that, I mean, he covered most of the stuff. I think more on a personal side, it was just hours ago. I've got a daughter, she's 13, and she was deciding which apps she wants to delete, like Snapchat or other ones. And she's asking me, I was like, well, why do you want to? She goes, well, I'm worried that which ones is using my data and I don't know what they're doing. And I said, well, all of them are using your data. Every single one that you're using, Instagram and Snapchat or whichever one. So you've got to just, there's no right or wrong, like which one I can recommend. It's just up to you. Do you want to use a product? Well, you're giving it up, your data. And so the fact that she's actually thinking about that and wondering that at that age is really good, becomes self-aware. And if that, if that movement continues and more people are like that are coming up, people are going to have to migrate to decentralized storage for that privacy and owning, like Gavin said, owning their own data. And the only way to do that is having your entire tech stack be decentralized.
Yeah, interesting you bring that up, because like the Web 2.0 platforms out there, the reason they're owning your data and we're not owning our data is that's how they monetize. So how can the decentralized storage layer somehow keep this free for users, or does it not keep it free for users to interact with new applications and still maintain these backend structures for any front end, say, future decentralized social network, for instance? How is it incentivized?
I think it'll be, and this is in the future, like not like right now, but I think eventually once more stuff is decentralized and people are doing it and they own their own data, I'm comfortable sharing that information with certain things. I just want to know who it is. So if I own my own data and everything that say all the payment systems are on the blockchain, I know who it's access to. So let's just say it sends me a quick request that we're going to do this with Nike. And I'm like, good, I'm a Nike fan. I'd love for them to know what tastes I have. Sure, go ahead and do that. And if the payments or that monetization has done that and it's tracked to my private wallet and I get a part of that, then I'm open game to that, right? Just let me decide and choose. I don't like, talking about something with, let's say you Phil, or you mentioned something, all of a sudden automatically my feed is full of those ads and they're trying to sway me in a certain direction. So I think that kind of thing is going to have to come up. And a blockchain could probably solve that, make it be the intermediary that actually connects all the pieces.
Yeah, Leo, do you have anything to add to that?
Yeah, actually, I think the very first thing is that we should, as right now, if we talk about big data, most of the data are still off-chain, right? And there's no any other like a blockchain mechanism built on top of that. So the very first thing is that we should enable, at least we should dig into this area and enable our users to put the data, or if not all the data, at least all the smart contracts and data metadata onto the blockchain, right? So that's the first step. And then after that, we should provide like a consolidated or compiled gateway or like a standard module for other blockchain or dApps to make use of. So that's actually a very big benefit that Polkadot gives the ecosystem, right? Because it has all the like the parachain mechanism and all the cross-chain interaction, besides all the asset and also the function and data messaging exchange. So that can be crucial. Yeah, that's my view.
Well, yeah, and adding to that, it's like, let's just say if Facebook wanted to do that profit sharing, give me some of that kickback. How are they actually logistically supposed to do that, right? Collect my information. Well, they're not going to mail me a check. Add a credit to my credit card? That's kind of cumbersome and costly for small amounts. Give me internal credits on Facebook. I don't want that. So really, it's the only thing you could do is like, once all this infrastructure is done, that the payment, the data source, the provider, all that's connected, that it can all be done through cryptocurrencies and validated on the blockchain. That's the best way to do it.
Yeah, that's a really good point. Yeah, great answers. I'm glad for that. Like if we do envision that the major part of the internet will eventually move to decentralized systems, including storage for the everyday user. We don't expect everyday users to maybe use these platforms in the next year or maybe 6 months or something. But what do you think are the biggest barriers to adoption right now? Not even for the everyday user, but let's say for dApp developers or even infrastructure providers.
Yeah, as I just mentioned, my point here would be, it is not like a one-time thing or 1 month thing, right? So it definitely needs a timeline. So I think it will definitely start as as to power a new set of applications like dApps for sure, and also with the technologies developing, decentralized cloud services could be adopted by applications that actually cares about privacy, right? Like the one, for example, all the Telegram chat history, all the privacy information, things like that. So it's better if we, got. There's it's like a process. So it's very lucky for us to, within this process. Yeah.
Yeah, I think it's funny you brought that, because I was talking to a crypto VC yesterday about the same thing, and I think what it is all our technologies are still relatively new and not battle tested. So that's kind of probably going to take that spot. So because one example as we're talking about is you've got some, let's say everybody knows Ethereum's congestion issues, right? That's like a beaten dead horse. Yet there are layer 2 solutions that can speed that up. And I was talking to one of them, why aren't just people just building on yours and using that? Like, it solves such a big problem. And his thing was, I think, because he said Ethereum has already got so much history and battle tested that people are willing to take that slowness, the developers, because they can trust it. Where the new layer 2s aren't tested enough and been through the wherewithal that they're going to put their full application on there. So same thing when it comes to, let's say, storage, whether it's file storage or data storage like us, is the centralized systems are kind of battle tested, they can trust and work. And as our main nets come out and more people are using it and they're seeing use cases and it's a bit more battle tested, then they can be like, you know what, let's migrate everything over. So I think it's just a matter of time and building that that trust.
Yeah, it's definitely still early days, and a lot of things definitely need to be battle tested. Once Bitcoin and Ethereum were in the same boat as well. People couldn't trust those systems for what they were claiming to do as well. So, like, getting a bit more technical, how does your network prove that participants are actually storing the data that users want to access later, and not doing the old the classic trick of being requested for that file, retrieving it from somewhere else, and serving it. How do we know that people are actually storing this data so that it can be reliably retrieved at a later point in time?
Yeah, there are actually, typically, there are two ways of doing that, right? So first is to introduce a set of validators that can be trusted, right? That's like, for example, Storj and some other projects are doing that. The other approach is that try to do that without trust any nodes, right? And actually, for example, Filecoin's proof of spacetime, they are doing that. And we are using a similar approach called MPOW, meaningful proof of work. So essentially, it's a off-chain. It's like a off-chain component. So basically, this component runs work inspectors. We call it actually storage work inspectors running within the trusted execution environment, which is actually protected by the hardware, so that the whole process cannot be tampered. So essentially, those work inspectors will check all the storage work on a regular time basis. Right now, we have set it to be like every half an hour. So every half an hour, it will go through all the storage orders and check if the local disk has really stored all those data, and basically generate a work reports and signed within the TE environment, and then upload it to the chain, right? So that is an off-chain part, but we use the output on-chain, so that with the transactions on the blockchain, they are able to verify all those work reports, basically to verify all the signatures. So that's how we are going to do that. Yeah.
Yeah, that sounds a little similar to how, Substrate has a function called off-chain workers, where it needs to verify off-chain data at any given time, and that sounds very similar. I recommend anyone who wants to learn more about that definitely look into Substrate off-chain workers or the Crust network, as you just mentioned. So, Pavel, do you have anything to add to that?
Not much. Ours is, because we're not focused on files where are the data, so it's a bit cleaner of what we've got to store. What we're really, ours is, hey, data is sent. It's written to the network. All our validators out there just kind of agree that the rightful person sent that over, and we pick all the mini hubs and zones where it would be stored, and then when the reads are done, it basically pings it to the closest one to them at that time.
Okay, yeah, I did notice that you for Bluezell, you don't compare yourself directly with AWS, but more to like Oracle, and like the things they've done. Could you go into a bit more detail about that? About the service you actually provide, as opposed to like just file storage and verification of those files?
Yeah, so ours is more like a MongoDB, right? And the thing that we want to provide as a NoSQL database is just quick reads and be a replacement for whether it's MongoDB or I can't remember what the other ones are. The fast caching service, Redis. Yeah, that one. So ours is really designed about just speed and having a lot of validators out there that just kind of just pinpoint and validate where the which node there's a bunch of nodes that'll have that data, and just pointing out that, okay, which one is the fastest that will just basically relay that information to the user at that time. So it can just bypass any congestion issues or latency depending on the internet connection.
Okay, cool. Yeah, so just a quick reminder to people, you can ask questions below and answer the poll. So please do that if you have any questions that come up during the panel discussion. So the next question goes into a bit more from the Polkadot angle, because Polkadot, a big major component of Polkadot is the notion of interoperability. We don't believe that one chain is there to rule them all. So how does interoperability between different blockchain platforms, how does that benefit your project?
Actually,
go ahead.
Go, Pavel.
Okay. It was, for us, extremely important. From day one, we had decided that hey, who knows which blockchain is going to win, and there's be different use cases, specializations for each one. So interoperability was key for us from the start. And then working with Polkadot, obviously is like, we can't go and build bridges to each single one, every single blockchain that's going to be out there. It's that our resources should not be spent on that time. It should be just focusing on the database and adding the different modules that we're building on top of, like such as statistical analysis, or now we're doing a decentralized Oracle solution that extends our database. So if we focus on that and leave, the interoperability, if we're connected to Polkadot, and then other blockchains or other projects are connected to Polkadot, then it's like, hey, Bluezell is available for them as a storage layer, and saves us all that time and energy from building those individual integrations, which could take, you guys specialize all of this. We don't want to spend all that energy. We could do something else that's better for ourselves.
Yeah, Leo?
Yeah, so from our point of view, like the interoperability of Polkadot is crucial to our projects, like in two different ways. So the first one is that we actually are expecting our storage users to be able to pay in stable coins, basically like maybe USDT or AUSD to, buy all the storage services. That can be much easier for them to use our service. That's definitely one. So that's one big benefit. And second one is that we are kind of focused on the file storage, right? And definitely after the file being stored on the cloud, the next thing is going to be like to enable all the analyze and all the processing of all the data. So we cannot do all those things by ourselves. So that rely on other projects as well. So yeah, that's two different angles.
And adding to that, the intro is composed because if you're building a dApp, right, and you're in this space, if people are investing into blockchain, they're betting on the future of not just tokens, but dApps and then the core infrastructure. And so if you're building a dApp, you need, just like in the centralized version, like if I'm building a game or a chat app, I need file storage for a layer and somebody doing data storage. So by us being complementary on Polkadot, now if somebody's building a dApp, they can go, okay, we're going to use, with Leo's, with Crest Network, we can use file storage there. And we've got Bluezell already on Polkadot. They'll do data storage. They don't have to do any extra work. It's just kind of that one place they can go and easily use both critical components.
Okay, yeah, we do have a lot of questions popping in. That's great to see. But I have just one more question before we get to the audience ones, and then maybe we'll still have time for more of my questions. But okay, so will decentralized storage compete with traditional cloud providers, or is it best suited to power a new set of applications entirely? Or will there be overlap? Leo?
Go ahead, Leo.
Yeah, so I think there will be a certain amount of overlap, but definitely we will start with the dApps. That's the point I made before, right? So definitely traditional cloud services is not very good for dApps requirement, that's for sure. But then after that, that's our kind of like a start point. And after that, what's going to happen is on all the applications that cares data privacy, right? That's also another point I just made. And maybe there are the third points that, the third area regarding the permanent storage and, to store store data forever or full redundant storage. So that's another area that centralized cloud cannot address. So I think those are kind of new areas with the new full set of applications for sure, but definitely there will be some sort of overlap, especially considering because all the public file, decentralized file storage, they are most likely incentive based, right? So at the early stage of the projects, the miners or the storage resource providers will get the incentive so that their storage services actually will be much cheaper. So that can be another attract point for all the applications. Yeah.
Yeah, building on that, I think definitely it's going to move over. We'll be able to compete on two ways. One is price. Decentralized networks will, from our calculations, I'm sure Leo has it too, is we're less than half the price that'll be for using a centralized solution. And then the other one is, I think it'll be consumer demand. People are going to be demanding, hey, where's my data held? Where is it stored? How can you prove that to me? And even if they don't want to know the technical details, it almost be a competitive advantage of new applications coming up saying, we want to compete against the existing incumbent and say, hey, you know what? We can protect your data. Why? Because our infrastructure is on a decentralized network. And, you know, it could, like I said, it'll be a competitive advantage they can use to position themselves against some of the incumbents. And it'll be a user demand thing from the end consumers.
Okay, really good answer. This is really, I'm learning a lot here too. So let's get on to the audience questions then. Micha has a question for Pavel, which is how are queries done on Bluzell? I mean, queries like all documents that start with the letter A.
It would, well, yeah, that would get pretty technical for myself. So we're not document storage right now. We're key value store. So it's a specific thing. So really, it's, I guess, I couldn't even answer that in a technical way. It's, you know, when the data, it would just operate just like any other NoSQL database that somebody's doing. The main thing that they're getting from us is the security and the privacy. And like I said, the benefits of decentralization, which is cost, security, censorship resistance. How it works would be any other developer who's used a NoSQL database like MongoDB, it would work the same way. You know, the languages are the same. The main thing is not to make them learn anything new and disrupt their developer's behavior of how they work with a database. It works the exact same way. You just have the benefits of decentralization in there.
Okay, cool, thanks. The next question from Lana is decentralized databases run into issues with GDPR. So for those who don't know, GDPR is a European set of rules that are very strict on data privacy. So this may not be known to everybody, but there are some very strict guidelines on how data should be stored in the cloud to be legal in Europe. And one of those such strict regulations is this so-called right to be forgotten, which is a way where I can have my, say I have a Facebook account, which I don't, but if I were to have one, I could request that they actually delete my data, and they would need to, by law, delete my data. Okay, regarding things with privacy and data can't be leaked out, how do you work with like such regulations, or what is the workaround for making sure that private data can be deleted?
Leo, go ahead if you want to take this first.
Yeah, sure. So I think there are 2 points of this related to this. So the first one is that the important thing is that in a decentralized world or a blockchain world, code is law, right? So everything can be auditable. So basically, if your protocol is supposed to support that scenario, then your code should prove that, right? And that's actually what we are doing right now. So if you look at our code of implementing the Crust protocol, then it includes all the code of how to make sure that whenever clients send that request, we are going to do it. Specifically, with something can be very hard if you don't have any additional support like TE, but you know, we got that hardware like enclave. So basically, we can make sure a lot of like tricky things can be guaranteed to be executed. So that's definitely one point of looking at that. So the second thing is that if you want to run some, let's say a cloud storage business with under regulation, specific, especially within specific areas like, for example, China and Middle East, then you have to obey some governance rules, right? But luckily, all the governance rules are more on the application operating side. So there are a lot of workaround on that part. So for example, you before you really upload any files onto the cloud itself, you can request to a third party like authorized organization to do all the content auditing, things like that. If you really want to run that legally in that particular area, then yeah, you definitely get the workaround. But other than that, definitely you can run that globally. Yeah, that's my point of view.
Okay, great question. Let's just try and get through a few more of these since we only have a few more minutes. So the next question is from Chris, which is, do all nodes have to store all the data, and how are scaling issues being dealt with?
Oh, solid question. So how it's designed is, no, they don't all need to do it. We've got to calculate a sweet spot of basically, you know, a certain number that would be redundant enough that they store enough copies that, hey, if something goes down, they'll be okay. And the odds of having X number go down is really high. So we don't need to have hundreds of them all having the same copies. And what that allows us to do is scale faster. So, you know, we can actually region them out that, hey, this is the Asia region, you have coverage in Europe, you can have the globe, certain sectors. So we can break it all up by having those sweet spots. So we call them just basically mini hubs along the bigger hub.
Okay, yeah, good answer. So for the next one is, IPFS on mobile is a battery killer. How do you enable mobile apps? Are you targeting mobile apps right now, Ian? Leo, do you want to go for this one?
Yeah. So actually, we are not trying to solve everything by ourselves. As I mentioned, so Cross is basically an incentive layer built on top of all the storage level protocols, including, like right now we support both IPFS and fast DFS, which is basically a derived version of GFS. So we don't intentionally want to solve all the file system problem. So to that question, definitely it's better for IPFS community to fix that, but definitely we will try to contribute on that one as well. Yeah.
Okay. Okay, let's do one more that I wanted to pick out, which is, we've kind of hinted at this, but it wasn't so clear, which is, how does data privacy fit into this? We talk about putting our data onto an open distributed cloud. How is it kept private?
From our side, it is, once again, none of the nodes have no access to what's stored on there. So that's all encrypted. The only people who can read that data are the ones who have their private keys. So just like, you know, your crypto keys, if you don't, you know, don't give up the keys to somebody else, and then they can't come in, look at the data or change it. So we're using just basically the basic element of cryptocurrencies of privatization, and your security is there. But the weakest link is going to be the individual. So if you leave your, you know, your private keys lying around, well, there's nothing we can do to stop that or prevent that.
Yeah, Leo, do you want to add anything?
Yeah. Yes. So we are doing like a 2-layer of encryption. So first one is on the client side, like that is pretty common. Like everybody needs to encrypt their data and take the responsibility of managing their keys. That's for sure. That's one. And secondly is on the node side. So on the node side, we actually do 2 things. One is we seal everything, like everything that stores in the node need to be sealed and unsealed when take in and out. So that's one. And secondly, we got the enclave to securely store the all the data owner's keys, because it's secured by the hardware. So, you know, it's kind of like a sandbox or a safe box. Whenever you want to enable that, then you should be able to get the benefit of that. So that's what we are doing here. And also one more thing I want to mention is that I do see there's a question regarding the TE technology itself, but just one more statement that we are also following all the open source TE technologies, like for example, the Sanctum and Keystone, which is actually supported by the MIT and UC Berkeley. It's basically on top of the RISC-V, and we do have a local research institute partnership. So, you know, basically we are working on that, and definitely we will try to adopt that whenever it's possible. Yeah.
Great answers today. Thank you, Pavel and Leo, so much. I know it's late there, so we're going to be wrapping up for you guys. There are many more audience questions. If you happen to be staying on in the background here, you can comment and answer those. But I guess it would be the best way for you both to just mention where people can get involved just really quickly.
For us, the easiest thing is if you go to our website, you can join our Discord channel for the developers out there, and they can directly interact with us. For general information, join us on Telegram or Twitter. So on Twitter, it's Bluezell HQ. On Telegram, it's Bluezell. And we can just directly answer questions or direct you to the right place, depending if you're a community member or a builder.
Great. And Leo?
Same as me. So go to our website and you can see all the channels, like all the Telegram and Twitter, and do follow us and raise your questions to us. Yeah.
Great. Thank you so much again. I think everyone has a huge, deeper understanding of decentralized cloud storage and what Bluezell and Crust are offering. So now we're going to move on to a talk by Michelle Lee from Filecoin. Thank you again. And Michelle, off to you. If we can get, there we go. And just as a reminder, while Michelle's getting on here, please continue to add your questions and answer the poll. While Michelle's speaking, you can definitely ask some questions that she will be answering at the end.
Thanks, Phil. Hi, everyone. My name is Michelle Lee from Protocol Labs. If you give me a moment, I will get the slides sharing. Okay. It's great to be here. Thank you so much to the organizers of this event for putting this together and bringing us all together as part of this series. Like I mentioned, I work at Protocol Labs, and we are an open source R&D lab. We build protocols, tools, and services to radically improve the internet. And you might know of some of our projects like IPFS, libp2p, and Filecoin. Today, I was asked to talk a little bit about what it's like to be building the components of Web3. And so I wanted to talk a little bit about why we're building for Web3, what our motivations are, and then also some of the design patterns that inform all of our many projects, because Protocol Labs isn't just one project or one technology. You can see we have dozens and dozens in the pipeline through this kind of R&D process. So why do we want Web3? I think there are a lot of different reasons. So, maybe the Ethereum folks will say, hey, we want a stateful web. We want every transaction, every piece of data to be attached to a state so that you can verify it in a trustless way. And that state can be transferred across applications independently owned by individuals, et cetera, right? So maybe that's one reason for Web3. Another reason might be that we want a semantic web. So we want all the content on the web to be able to semantically link to each other and essentially build a knowledge graph for humanity. We might want Web3 because we want a censorship-free web. We want to be able to ensure that data makes it from one point to another in its original state as the authors intended. We might want a people's web. So we want a web where data, just like Pavel was saying, is controlled and owned by individuals who generate it. And only we are the ones who are able to give permission to applications and systems to use it for a purpose that we know about in advance. We might want an open web. We may want more free-flowing information between different systems and networks. So at Protocol Labs, when we think about building the decentralized web, all of these motivating factors are there, but there are two that stand out, I think, especially. The first is a decentralized web in terms of control and governance. And then the second is a content address web, which enables a lot of efficiencies. I'll go more into that in a little bit. But the first one, it's been said that 90% of web traffic now flows through Apple, Facebook, and Google. And that's kind of a product of the Web 2.0 era, which has been really, really convenient. It's enabled the development of a lot of fantastic applications, transforming not just technology itself, but essentially technology enabling every single industry out there, from shipping to food to mobility, transportation. But these monopolies are also really vulnerable. They're vulnerable to outages, to censorship, to surveillance, to skewed perspectives. And so we find that right now power is far too decentralized in the web, and we need to go back to the roots of the internet from the 60s and 70s, where the idea was to build a network that was resilient to an attack on any single major node. The second is this idea of content addressing, because I think what the most exciting thing in cryptography for us is the ability to use these cryptographic hashes to essentially fingerprint unique pieces, small building blocks of any kind of data out there. So instead of referring to data by its file name or its version, etc., we can with extremely high confidence know that we can refer to it by a hash and then get the data that we were intending to receive. This is a really, really key innovation that supports deduplication, verification, and all sorts of other things I'll go into in a moment. So if our motivation is to regain control of the internet from tech monopolies and encourage decentralized building, it stands to reason that there's tons of variety in decentralized web projects. So I think at last count, over 12,000 companies received funding via ICOs, and that's just token projects specifically, not to mention the thousands and thousands of projects and companies that are building on top of those. But even as this space matures, we don't want to see the type of consolidation that Web 3.0 went through. Every technology, every stack, every platform has its strengths and weaknesses, and we want developers to be able to build on top of the best tech stacks for their goals and be able to remix components. So how do you design for openness and interoperability on one hand, and also progress and performance and maturity on the other? There are a couple design patterns that are coming to the forefront now that Protocol Labs has been around for, I believe, five years, and the ideas and inspiration behind that even further back. The first one is that protocols should be self-describing. The second is this idea of graphs over lines, and then the third is an idea of small pieces loosely joined. And these are all design philosophies or design patterns, if you will, that are shared by all of the many projects that Protocol Labs either originated or is deeply involved in. And each of them speaks to that dual governance and technical motivation that I talked about earlier. So let's go into some examples, because I think these taglines are pretty blurry, but hopefully they'll make sense once I show the examples and how we're using them in our systems today. So one example of a self-describing protocol is Multiadder, and it's a very, very simple format. It's a one-liner. All it does is encode addresses from different network protocols. So in the beginning, in the upper right, you can see you can give an IP address, but it's unclear if it's TCP or UDP or what kind of internet address it is. And then we may not know if a given address is IP4 or IP6. Who knows, right? So all we're doing with multi-adders is just putting a header on it, putting a prefix that describes what protocol it's using, and then give you the value, as we always did. What this does is, one, it future-proofs your address format, because if an IP7 comes in the future or DNS8, you'll be able to refer to the different protocol versions, and it also makes interoperability a lot easier, because you can just when you start parsing the string, you can get the format and then interpret the value according to that. So very, very simple example of a self-describing format. Another example of a self-describing format is part of the IPLD project, Interplanetary Linked Data. And IPLD is super cool. It's a set of specs that enable linking deeply and specifically into decentralized data. It has a bunch of components. You can read more about them at ipld.io. But a really, really key one is the ability to build a DAG, or a directed acyclic graph, out of your content, and then traverse it through selectors to not just get the entire graph, but get only the parts of the graph that you want. And then the part that's self-describing that we're going to talk about here is when you flatten it for transport. We have a format called CAR, which stands for Content Address Archive, and every CAR you see this orange part here, has a header on it. And that header includes the root CID, it includes other info so that you can fetch certain paths or use selectors to only retrieve part of your graph. And this can be used, not just in your application or your storage system, but it can also be used to specify reads in and out from another system. So if there were, another way to say self-describing, it's essentially put a header on it. So all of these protocols, all of these kind of microformats really, really benefit from having something up front that tells you what format we're using. The second design pattern I want to talk about is really messy, and I think it's one of the biggest learning hurdles to jump over when people are making that transition from Web 2 to Web 3, and even kind of from the early days of Web 3 into how we are designing now, and that is graphs over lines, like floods over rivers. We send a lot of data at once and then have smarter ways of interpreting it. So one example is the Filecoin tip set. So in the upper right, this is a description of a simple Bitcoin blockchain or illustration. And in Bitcoin, we simply take the most recent block, the heaviest, the latest block, and then sometimes you can get orphans or have forks. But all we're doing is reading kind of at any given time the rightmost block in the chain. Filecoin works a little bit differently. It uses a design, kind of like a heaviest first design. And instead of just drawing from a linear blockchain, it draws from hundreds of blocks actually. And it calculates the weight of each of them and to identify what is the correct block. And so you don't need to, it allows you to bypass the weight for one block at a time. You can fetch the whole tip set at once, and it really is a way to increase chain throughput that way. So graphs over lines. Another example of graphs over lines is actually, again, an evolution from early days of Web3 to today. And that's the Graphsync protocol. It's a way to synchronize and basically swap data among decentralized data networks. And in the upper right, you can see how BitSwap, which is the original protocol, worked. You send a CID, you get a block. You send a bunch of CIDs, you get a bunch of blocks. So 1-to-1 ratio. With Graphsync, you send one CID and some metadata, and you get a whole bunch of blocks in return. So you, in the diagram down below, you might just send the CID of this, this topmost circle, and you can say, send me everything from, that within that metadata, you can say, send me everything that CID points to, or you can say, just send me the green stuff, or just send me the orange stuff. And that becomes a really, really specific, a brief way to get to specify what data you want, and that data can be small or large depending on how you structure your selector. So again, graphs over lines, and I think something that's very common across both of these is that it really enables much faster throughput. You can send a whole bunch of data at once. You can even start prefetching some of the data before when the CID comes in, and then only queue up the selected blocks for transport once once the metadata is parsed. It really gives a lot more flexibility, and it allows you to essentially go a little bit deeper beyond that. The single block structure to fetch data across networks, across storage systems. Graphsync is used in the Filecoin network, and so when you store data on Filecoin, even though it's kind of partitioned into pretty sizable pieces or sectors, the design is such that you'll be able to use a selector to just extract exactly the data you want and use it in your application. The last thing that I'll mention is, this pattern of small pieces loosely joined. So in the background, we have a diagram of the Web3 tech stack. There are a million ways that you could write this diagram. But Filecoin, for example, is our most recent and potentially our best known project, but it builds on all of these, all of the technologies I mentioned so far and others. And you can see, libp2p focuses really on that, that zero layer as an internet protocol. IPFS and Gossip Sub are focused on the next layer above it, and then Filecoin wraps around all of these and uses many of the components that were developed during the course of building IPFS and the P2P, et cetera. And what this does is it allows for a lot of future interoperability, both between projects that Protocol Labs has created, but also external projects as well. We've already started integrating signing tools with cross-chain projects, and breaking any of these projects down. Just looking at the GitHub repos, they have many dozens or even over 100 sub-libraries or sub-repos, and that's a design pattern, very deliberate design pattern. It's an opinionated one, it can be messy, but it is also really empowering. So that is a tour of some of the design patterns that we use when we're building Web3 technologies at Protocol Labs. We want to create really excellent small options from the design and governance and performance perspectives, and we want to encourage Web3 builders to use these in ways that enable the future of the web. That's it for me. Thank you.
Thank you, Michelle. Let's go to some few of the audience questions here. One question that came up was if you know which is the main difference between Filecoin and other decentralized systems like Storage or Storage, for example.
Let me pull up the Q&A panel here. Okay, great. Like we said, we're in the really early days of Web3, and so we have a ton of different projects that speak to decentralized storage. I think one thing that, like I mentioned, Filecoin is really focused on is this interoperability and reusability. So we're building on top of the IPLD, IPFS, libp2p, and we believe that Filecoin is going to be not only the most flexible and interoperable, but I think also hopefully bring a lot of the foundational work and carry it through, so that it's not the Filecoin brand that is most prominent when developers think about using it. It's that Filecoin enables content addressing IPLD selectors. It's the most reusable, it's the most flexible, and it's also the most secure out of all of them.
Okay. Another question is, are there any examples of IPFS-based databases and how they perform?
There are some really interesting, there was a paper I saw from a few years ago, and I don't remember the author or the name of the paper, I'm sorry, but that kind of using this graphs over lines pattern, certain AI projects or large data projects, I think some TensorFlow calculations more efficient if you could run the calculations locally where the data was stored.
Okay, we have a question in the chat from Marcel, which asks if there will be minimal light clients for Filecoin. Is that in the works so that people can easily connect and verify storage proofs?
Yeah, our early implementations have focused on full node implementation, so that carries with it all the functions of the network and can be really heavy. I think the proof verification is probably going to be really difficult to isolate as a light client, because that's the heavy lifting of Filecoin, right, and its proofs. Where I think we'll see light clients is on the retrieval side, or kind of an end user application that might perform just some of the client functions or signing functions or message transaction functions instead of the full node. That's much, we have some of those in the works already. Some of those are in beta. I would look there rather than the proof verification side if you want a light client.
Yeah, cool. So what are the best ways, like, let's say I have a tons of extra storage space, like what would my role be in the Filecoin network, and how would I be reimbursed for serving that data?
If you have tons and tons of static storage, you're probably suited to be a storage miner. If you have a modest amount of storage, but connected to really, really great bandwidth, you might be suited to be a retrieval miner. But let's talk about storage mining first. In Filecoin storage mining, you advertise prices on the network, you receive a bunch of deals, and then you perform a process called sealing them, which is not like wrapping them in an encrypted package, but is really, think of the like the postmaster interpretation of seal, or the Chinese signature stamp. You essentially timestamp it and say, I've got it now, and then I have to continuously submit every 30 minutes, every 24 hours, proof that I still have it stored, where I claim to be, and incrementally you get paid out for that storage over time.
Okay, cool. Yeah, thanks. What is so recently Filecoin launched something interesting. It kind of relates to something that Polkadot has done with our launch of Kusama last year as an incentivized testnet. So could you talk about the space race testnet for a bit?
For sure. So the space race was a 3-week incentivized competition, and the goal was to onboard as much storage as possible into the Filecoin testnet, which had been running for several months already, but without the level of kind of incentivization and excitement and events and community building around it that we added during space race. And we originally set a target for 100 petabytes of data. Quickly saw that people were going to exceed it by far, and ended up storing more than twice as much, adding twice as much storage into the network. So it had a lot of goals, and probably like other incentivized testnets, it's really wanting to bring out realistic behaviors, market dynamics, the kind of convergence chaos, and then or chaos and convergence of a decentralized network. And so we saw all sorts of bad behaviors that allowed us to plug some holes in the protocol. We saw all sorts of community members helping each other, with like configuration recommendations. And at the end of the day, I think really added to our confidence heading towards the main network launch. We have, I think, especially in the 3rd week, I'm not sure if you were, anyone here was involved in space race, but we threw a lot of wrenches into the mix deliberately. There was an outage, there was a planned hardware, there was a planned protocol upgrade, there was a second planned protocol upgrade. So we kind of threw every wrench possible into the network and looked at how recovery worked. Miners were really, were amazing. They were really, really game for all of this chaos, and worked really hard to make the best they could. In the end, we ended up finding that we really wanted to improve some of the proving, fault tolerance, and recovery mechanisms. So that's been very exciting for our team to learn and work on. We'll be releasing some upgrades soon based on those findings.
Great, that sounds really cool. I love all this wave of incentivized testnets going around, and attack nets, and all these other new projects to really get these projects more quickly off the ground. So just to close out, what's the best way people can get involved or contact the Filecoin team and ask questions and find out more?
Probably the first and most dynamic way to get involved is to go, well, there are two. I'll say, if you go to YouTube and look for the Filecoin channel, there are tons and tons of videos, both in big picture and more in the weeds about Filecoin. So that's a good place to learn more. But the place to come and get engaged and involved is on our community Slack, which is also bridged to Matrix. So filecoin.io/Slack is where you can sign up and join us, and you can look for different channels depending on your interests. If you're interested in storage storage development or mining or certain implementations or cryptography, you can find us there.
All right. Well, thank you so much. It was a great presentation, and we were so happy to put this together and have you involved.
Great. Thank you so much for hosting.
Thank you. Thanks, everyone, for joining. Have a great day.